Jaskula, and I'm a PhD student from University College London. And my research is a part of the CBIM project, which is a EU-funded project by Horizon 2020. And today I will present you a conceptual framework for decentralized information management. So I would like to start with explaining the different dimensions of industry fragmentation, which actually occurs on 3 different levels. So first of all, we have the horizontal fragmentation, as we have always multiple parties working together on the same project, like architects, engineers, contractors, and so on. And they are always isolated companies, usually small, medium enterprises, and this isolation creates barriers to effective collaboration. And secondly, we will also have a vertical fragmentation of construction projects. As they are very sequential, each activity can only take place after the other one completes. So the life cycle is divided into different phases, such as design, construction, and operation. And the integration of data between those phases is also difficult to achieve. And then lastly, we also have a longitudinal fragmentation, which occurs to the uniqueness of construction projects. So each project is different, and it also involves a set of different stakeholders working together. So also the learning process from project to project is difficult to achieve. And except of the fragmentation, we have also other problems which are kind of results of this fragmentation. As you probably heard, construction industry is one of the least digitized sectors, and the adoption of building information modeling is the base of the digital transformation, but the centralized BIM solutions also have some weaknesses. Using shared BIM models raises concerns about data security, data ownership, legal implications, and responsibility distribution in the BIM, in the shared models. This collaboration process generally suffers to lack of transparency and accountability, and therefore there is a general lack of trust between the construction stakeholders. About the information management, it is described by the ISO 19650 standard, which describes where the information management is based on the using of common data environment, in short CDE. So common data environment is or should be a single source of all information about the project along the whole life cycle of a built asset. But in practice, the CDE is usually a cloud-based repository, and there are many different solutions from all of the big companies or big software vendors like Autodesk or Trimble, Oracle, and so on. But the stakeholders are also using simple cloud-based repositories like Dropbox or Google Drive. And in the operation and maintenance phase, it's even more complicated because there all of the system change. People are using KFM systems or CMMS systems or building automation systems and so on. So the integration of data and those transactions between those different software is almost impossible to track. So we have a very low integration between those systems and low traceability. So in general, we have few problems of the centralized CDE solutions. First of all, a high vulnerability to security risk, such as data loss and denial of data access and partial control over sensitive data, as usually these CDEs are owned by one party, one of the stakeholders, who can also manipulate the data to their own advantage. And in general, we can say that the centralized solutions are not suitable and compatible with the fragmented nature of construction industry, and they create a single point of failure. In contrast to the centralized information management, we can also propose a decentralized information management, which is more similar to the construction industry network. The blockchain is also based on a distributed network of nodes, and they all have a copy of of the ledger with transactions, and there is no need for a third party controlling the network. So the main advantages of blockchain in construction is the high transparency and traceability of the records, and at the same time, very high security and also immutability of transactions. And there are also a lot of different applications and use cases already proposed by different researchers for construction industry. For example, for a design phase, we could have a record of BIM, of changes in BIM models, or the record of ownership, or also compliance checking. And in the construction, blockchain can also help with tracking of supply chain logistics and payments, and also the material and product passport that we already heard about in the last day. And in the operation maintenance phase, there are also applications for automated building maintenance systems or record of maintenance and operation data. But all of those applications are usually focusing on a very small scope, so only mostly on 1 or 2 design or lifecycle phases, and they are not integrated with each other. There were also some proposals for the centralized common data environment. So, for example, a framework for a construction document management system based on Ethereum and IPFS, or another proposal for distributed CDE for design phase based on Hyperledger Fabric and IPFS. So the IPFS is a peer-to-peer network for storing and sharing data in a distributed file system, and it facilitates data integrity and also enables to store large-sized files such as BIM models. So to sum up, the research gap that I'm focusing on is threefold. So first of all, the vulnerability of centralized solutions to internal and external security risk, and also the fact that the single source of truth described by the ISO 19650 is not really implemented in practice, as we always have those multiple sources of information in one project. And in the end, also the blockchain applications that are developed or proposed right now are usually focusing on only one application or one specific lifecycle phase. So our proposal would be to this conceptual framework for the whole lifecycle of a built asset for information management, which I will show you in detail in the next slides. So we will start first with the design phase. In the beginning, or the framework is based on the blockchain record of transactions, linked with the IPFS storage for storing large files. And the framework includes all of the stakeholders participating in the project, so the architects, client, contractors, and so on. In the beginning, when the project is initiated by the client, all of the documents created would be already stored in the blockchain, like the BIM execution plan or project brief. And then once architects and other participants are appointed, they would receive access to this information, and they could use this blockchain and IPFS storage for exchanging the different design variants. Sorry. So the blockchain CDE would be structured according to the ISO 19650 standards, including the different containers for work in progress, shared and published data. And then once the design phase is finalized, the final documents would be published, and the authorities who have to give the permission to build would also have access to see it and to give the permission. And then also the tendering procedure could be facilitated by this common data environment. And in the end, the final design and like design models and the documentation could be stored on the blockchain, and the contractor would receive this information. So in the construction phase, also the subcontractor would receive access to this data, and they could use it for uploading the information about the construction progress. And there also the product and material passport would be established, so that the data about the material and products would be already updated inside of the CDE. And once the building completes, all of the data would be already there in the CDE. So handover could be facilitated by using smart contracts. And then the facility managers would receive access to this as-built information. And in the operation and maintenance phase, the product and material passports would be still updated and reused from the previous phases and updated with the information about their maintenance or replacement and so on. So this whole chain of information would be not broken, but it would continue to the next phases. And then once a client decides to demolish the building or renovate the building, all of the data would be already available in the CDE. And in case of demolishment, the information about the available materials and products could be used for reuse or recycle purposes. So as this was a conceptual framework, there are a lot of questions for the next step of the research. First of all, how these transactions happening between the different tools would be really recorded on the blockchain. And then also a fundamental question is always which kind of blockchain environment should be used in this platform. So if it should be public or private or a consortium blockchain, as they both have different features. And also the question would be how this workflow could be used for other procurement routes, like for example the IPD. And these are the references that I used. And that's all. Thank you very much, and I'm happy to answer your questions.
Thank you very